Hi there, my name's Mike, and today I'll be teaching you how to make snake in JavaScript. It's pretty simple, and it's a really good project to have on your portfolio as a web developer, and it's also kind of fun to make. So let's get into it. To start, I'm going to, just open my desktop. I'm going to make a new folder, and I'll call this snake, and then I'll open that in VS Code. We're going to need two files for this project. I'll make an index.html, and then a main.js. You can call them whatever you like, but this is what I typically call my files. In index.html, I'm going to use the image abbreviation to get a basic structure, just a head and a body. We'll call the title snake. See if I can't get capital S. There we go. And then in the body, I'm going to make the script tag at the bottom and source in our main.js file. All we need in this HTML file is a simple canvas. Canvas is an HTML tag that allows you to make really cool stuff in JavaScript. It is an advent of HTML5, and you'll find that it's very nice to work with in JavaScript. To start, I'm going to ID this. I'm going to call it canv, and then I'm going to give it a width of about 500 pixels will be fine, and a height of the same. We're just going to make a square. We'll save that, and we're done with the HTML for now. Now onto the JavaScript. We're going to start by making a window on load function. So when the window opens, and on its load, we're going to do a function. This function is going to essentially initialize everything that we need. So we're going to save our canvas. So we're just going to get it from the document with getElementById. And the ID was canv, if you remember. Canv equals. There we go. Okay. And then we're going to get the context. So the context, I'll show you how to get it, and then I'll explain what it is. So what I'm saying is I'm getting the context in which we're working with the canvas. So in this case, we're making a 2D game. So we're getting the 2D context. You'll see that there's an experimental 3D version. If I do this, it should autofill perhaps. Oh, I guess not. There's an experimental 3D version that allows for 3D games. I've only ever worked with the 2D context, but this context object is what we'll be working with from now on to display our objects as we create them. So display our snake and our apples. Next, we're going to add an event listener. Events in JavaScript are essentially anything that the client does. So if the client clicks a button, an event happens. If the client moves his mouse, an event happens. And so we're looking for the buttons, specifically those 4 arrow buttons in the bottom right. We're looking to see when that happens and when those are clicked. So for our event listener, we're going to use the key down. And then when key down happens, we're going to run a function. We'll name that function controller later. Or I guess we can do that right now. We'll make a function down here. Let's say function controller. And then this, because it's an event, it needs to take an argument. We'll just call that event as the argument. And then when we get that event, we'll check through it to see what key is pressed. So to do that, we'll use a switch statement. And we'll pass through the event, and we'll pass through specifically on the event. We want to pass down the key code. Now, for key codes, I'll show you a cool tool that you can use to see what key you're using. If you look at JavaScript key codes, this keycode.info website, as I'm pressing keys, you can see, I'm just typing random things, that it's giving me the code for each key that I press. So the keys that we want are the arrow keys for our snake to move. You could also do WASD, but I'm going to use the arrow keys. So we can see 37, 38, 39, and 40 are our keys. So those are the keys that we want to look for. So in our switch statement, we're going to say case 37, and then we'll break for now. Then we're going to do this 4 times, looking for each of the cases. So we're going to do 37, 38, 39, and 40. These are all of our arrows. Just to make sure which arrow is which, I'm going to check. Okay, so the left arrow is 37. So we're going to make a comment. We'll say left. And then the right arrow is 39. I'm going to do this for all 4 arrows. up arrow is 38. And by process of elimination, the down arrow is 40. That's so that when we're working with our velocities and changing the speeds, we'll know which way is which is super useful. Okay, so we've built our controller. We can see when certain things happen. Let's test this really quick. Whenever I press the left key, I'm going to go ahead and alert left. So let's open up this file in our browser. Okay, press the left key and it says left. So our controller is working, at least for the left key, that is. Now we can go on to creating the main part of this, which is the main engine, the thing that's doing everything. The way we do this is essentially we want to run a function every certain amount of seconds. So every tenth of a second or however many frames, we want to run a function. The way we do that in JavaScript is we create an interval function. So all we have to do is say set interval, and then we say the function that we want to run. So in this case, we'll call our function main. And then we say the time at which this happens. This is in milliseconds, by the way, and I want the frame rate to be in frames per second. So I'm going to do 1,000 milliseconds over whatever our frame rate is. We'll make a variable called frame rate up here. Since this is JavaScript snake, the snake game is normally at about 10 frames per second. It's not very fast, but this can go anywhere. This can really be any number you want, as fast as the browser can go. So for now, we'll keep it slow at 10 frames per second. So 100 over 10, this is happening every 100 milliseconds. Our things are being computed. So let's go ahead and make that main function. It's called function main. And the first thing we want to do is we want to start defining some variables. We're going to need a velocity for our snake. That's the speed at which it's going. And then we'll change that with every key press. And then we're going to need coordinates for our snake, as well as a grid size for the overall grid. Because if you've played Snake, it's gridded. Oh, I forgot the var there, my bad. Okay, so let's make a velocity variable. We'll make a velocity x. We'll set these equal to 0 to start, and then we're going to make a velocity y as well. We're going to need positions, so we'll want player x and player y as well. And then we're going to want coordinates for our apple, the object that the snake is trying to eat. Okay, and lastly, we wanted to make that grid size. So we'll call this grid size. So this is how many pixels wide the grid is. We'll start with 20 for now. Now, if you think about it, we're going to need a tile size as well, because if the grid is 20 by 20 and our canvas is 500 pixels, we're going to need a tile size of the width, so the canvas width, so that's 500, over the grid size of 20. And that will give us whatever our tile size is. And that'll be useful for defining the width and height of the snake body parts and the apples, because we want those to all be 1 pixel wide. Oh, and lastly, we need to define some things for the tail. So we're going to make an array for the trail. We'll just keep that empty for now. We can push things into that once we start making our snake. And then we're going to want a tail length. This is going to be the starting tail length and the tail length that it resets to once you die. We'll start that out at 5. I think that's a good starting tail length. Okay, so up next, if we were to look at our file here, you can see it's just white. Let's fill the box with black so that you can see the width and height of the... Let's fill our canvas with black so that you can see the width and the height of the canvas. To start out, we're going to need to set our pen color. That's the way that working in context works, is if you want to change the color of something or fill something in, you need to set the color, and then you can define where you're going to fill in. So the color, we're going to use context.fillStyle, and we're going to set that equal to black to start, to make that black background. And then we're going to draw a rectangle with drawRect, and you can see that, I'm sorry, that's fillRect. We're going to fill the rectangle with black. And you can see that it's asking for an x coordinate, a y coordinate, a width, and a height. So the x and y that we want to start at, we want to fill the whole rectangle, so we'll start at 0, 0. And then the width is simply the canvas width. And the height is simply the canvas height. And if we check that, save that, and check, You'll see our black boxes there. This is where the snake will be moving around. Okay, so to start with our snake, the first thing we want to do is add in our velocity functions here. So if we're going to the left, we're going to want an x velocity that is negative. X. I'm sorry. So velocity underscore x, and that's going to be equal to -1. And then we're going to set our velocity y to 0. And we can just copy paste this for all 4, and then change the values one by one. So if we're going up, we're going to want a x velocity of 0 and a y velocity, believe it or not, of -1. That's a funky thing with up and down in canvases, is up is negative. Right is going to be a velocity of 1, and down is going to be a y velocity of 1. All right, and that looks good. So now we can plug that into our main function. So every time this loops, we want our position to update by our velocity. So we're going to say player x plus equals. So we want it to be equal to itself plus this value. And that value is our velocity. It's velocity x. And we'll do the same thing with velocity y. If we were to check this out, we would see nothing happen because we still haven't drawn our snake. But this is an important thing to do every frame, and it's the start of drawing our snake. Okay, so let's actually draw our snake. To start, we're going to set the pen to a different color. I'm feeling like I want my snake to be pink, so I'm going to make him pink. And then we're going to need to draw the snake. If you think about it, the snake is actually going to be several parts. We're going to score different coordinates in this trail array. So we're going to need to loop over this array and draw each individual coordinate in the array. To do that, we're going to make a for loop. So for var I equals 0, while the I is less than the trail.length, since we want to loop over the trail array. And then we're going to I++. So we're looping over this array, and we've got our pen as pink, so we can go ahead and draw. We'll do context for rect, and then the x is going to be the trail of I, and we'll save them as .x and .y. So .x, and then the y is going to be the same thing, but .y. And the width is going to be the tile size. Same with the height, because it's a square. And there we go. We've got our snake drawn. If we were to check this, we would see a problem. There's no snake, and that is because we haven't defined this trail array yet. It's currently just empty, so it's drawing nothing. What we need to do is push our current position to the array. So to do that, we're going to do trail.push. And then we'll just push an array, and that array will have x, will be player.x, or I'm sorry, player underscore x. And then the y will be player y. If we check this and try and move around, we're going to see a couple issues here. The first thing is it's less of a snake and more of a snail. To fix that, I made a mistake when I was explaining something. When we're setting our trail x and trail y, that is in terms of x and y of the canvas. We need that in terms of x and y of the grid size. So to do that, we're going to multiply by our tile size. So we'll do times tile size for all of our x and y coordinates. That was my mistake. So now if we check that, the snake is moving normally, but it's not disappearing. It doesn't have a tail length, it just has an infinitely long tail. And so the issue with that is that we're adding our current position to the array, but we're never removing the old positions. So to fix that, we're going to use a while loop. So we'll do while the tail size, or I'm sorry, tail length is less than the trail length. So we're saying if the array is longer than the length. So if this array has 5 things in it, and the tail length has 5 things in it, then we'd be fine. But if the tail length was 12, and we had 5 things in it, then we would need to do something, right? So what we'll do is we need to get rid of that first element, because if you think about it, we're adding on here. With .push, you add on to the end of the array. We're adding new content onto the end of the array. So we need to get rid of the beginning of the array, because we're kind of shifting things in order. So we're adding on at the end, we'll subtract from the beginning. So we'll do trail.shift. That is the, if you check the tooltip, it removes the first element from an array. So now if we check that, we'll save. We can move around and we have a set length of 5. Now the issue is when we go off screen with our snake, he just kind of disappears. We don't want that. I think the classic snake style is to kind of wrap around. So to do that is pretty simple from a programming standpoint. All we need to do is check if the snake's coordinate is about to be bigger than the actual grid size. So after we apply our velocities, we're going to do a couple of if statements, which do if player x is greater than the grid size, and we'll do -1. Then player x is equal to 0. So we're going to wrap around. So the reason we did -1 there is because if you think about it, coordinate started 0. So it's really going from 0 to 19. If it was in coordinate 20, it would disappear. So we'll reset this to be back at the beginning. Now we need to do that for the y as well. And then we're going to need to do this for the inverse scenario, where instead of wrapping to the right, if we want to wrap to the left with the snake, so we'd be checking if we're at 0, and then we would go to grid size -1. So we'll do that with both of them. So instead of 0, and this is less than 0 this time, instead of greater than 0. Same with this one, less than 0. And then we'll set that to grid size -1. And we can do that for both of them because they're both, since it's a square, right? It doesn't matter. Grid size -1 of y is the same as grid size -1 of x. Okay, let's try that out. We can move around, and I can wrap around freely. Okay, so all we need to add is going to be the apples and the score counter. So to add the apples, this is a lot easier than adding the snake. So we just need to change our pen colors. We'll make this red for the apples. Fill style is equal to red. And then we need to fill in the rectangle for where it is. So we'll do context.fillRect. Oh, whoops, that's rext. Let's see if I can type. And so the x coordinate is going to be that apple x that we defined earlier. The y coordinate is going to be apple y. Let's check what those are. So right now, apple x and apple y are the same as player x and player y. That'd be kind of annoying and unnecessary. So we're going to set that to about 15 just for the first apple. And we'll start the player in the middle this time instead, just to be a little more clear. So fill apple x, apple y. Oh, and we need to remember to do our times tile size on those x coordinates so that it's to scale with our page, so we don't get that weird slug thing going on again. And then the width is just going to be the tile size. Okay. Oh, almost forgot a semicolon there. Let's check that. So now there's an apple. We can't quite eat it yet, but it's there, and it is on the grid. So now let's set up eating it. To do that, all we need to do is check the position of the apple and see if it's the same as the position of the player. So we're going to do, let's do this before we draw the apple. I'm going to say if player x is equal to apple x and player y is equal to apple y. If that is true, then we're going to want to add 1 to the tail length. And then we're going to want to put the apple in a random position. To do that, we're going to need to reset the apple x variable, and we're going to set that to, okay, so math.floor essentially just rounds the number. So instead of 10.5, we would get 11, because we're going to use a random number to generate our coordinate. So now we're going to get our random number. We're going to do math.random. And math.random returns a number from 0 to 1. A random number from 0 to 1. So to get that in terms of our scale, we just need to multiply it by the grid size. So we'll do times grid size. Okay. And then we need to do that for y as well. Okay, and we're good to go. Let's open that up in our game. So now if I get this, it spawns over there. And you can see that our tail is indeed growing larger. But we can't see our score yet. That's the last thing I'd like to do. So to write text with context, all you need to do is, well, first let's make it white so that it doesn't get confusing. Oh, whoops, equals white. Next, you need to set the font. So we need to do context.font. And we set that equal to 30 pixels, just Arial is fine. And then we can do context.fillText. Whoops. Text. And the way you do fill text, it says here, is you put in the string, and then you give an x and a y. So the string will say score, and we'll put a colon and then a space, and then we'll add let's see, we'll do the tail length. Make sure to do this in parentheses so it knows what to do first. Tail length, and then we'll do -5, because the first 5 points that you get aren't really points. We want our score to start at 0. And then for the x and the y, we'll just do 20, 40. And let's see that. Okay, there's our score display. If we walk around, we get an apple, and our score is going up. So that is a completed snake game. I hope you enjoyed the tutorial, and I hope you enjoy your snake game. It's a fun portfolio project, and it's just a nice, easy thing to do. So thanks for watching, and I hope you enjoyed the video. If you liked the video, please do like and subscribe, and I'll see you next time.